It's okay. Now everything we said is recorded, so Tal, you can go.
Okay, so thank you very much, Andrea, and thank you very much for inviting me. I'm very excited to be here with this group, and as you said, like it would have been nice to meet physically. I've never been to Milan, and I really hope that next time it's gonna be in person. So today I'm going to use the time that we have together to talk with you about how you can use LakeFS to build a reliable version data lake. And before we get started, I'm going to tell you a little bit about me. So my name is Tal, and I live in Israel, and I work as an R&D team lead at Treeverse, which is the company behind the open source product LakeFS. I previously worked in a company called Urbanomic as an engineering manager. And the agenda for today's conversation, we're going to talk about the following topics. So we'll start by talking about data lakes in general, and data lakes are the problem space in which the LakeFS product operates. Then we're going to cover the difficulties that you all know and you have these difficulties in your day-to-day work with data lakes. And then I'll show you how you can use LakeFS to overcome these difficulties and build a reliable version data lake. And I'm going to end this talk by running a quick demo that hopefully will show you how easy it is to use LakeFS to overcome the difficulties that we will go over. So the whole premise of a data lake is that I have this one big place, one big central repository where all the data in my organization is stored. And all the applications in my ecosystem, they can access this one big place because they all speak the same language. So for example, I can write and read files from S3, and I can spill Parquet files from a Kafka topic into S3, and then I can use Presto to query that data. And everything works because the lowest common denominator of all these applications is S3 and flat files. And it's really great architecture with a very rich application ecosystem. It allows me to pay an affordable cost and store tons of data. And also, you enjoy this extremely high throughput provided by the object store providers, such as S3. And it sounds quite ideal. But in reality, this architecture also creates quite a few problems. So now you have this one big place where everything is stored. And this one big place actually behaves like a huge shared folder that becomes really hard to manage. And if you think about the challenges in managing this huge shared folder, you will notice that they're quite similar to the challenges that we experience in managing shared code repositories. So for example, with data lakes and with code, you would probably like to have a place where you can try out your changes in isolation. And also, you would like to be able to control whatever gets into your lake, the same as you do for your code repository. So if the challenges are similar, and we already have best practices to manage code, so why don't we do the same for data? In a perfect world, we would want to be able to manage data the way we manage code from development to production. And this is exactly why we've built the open source product LakeFS. And if I have to squeeze the explanation of what LakeFS is into one sentence, so I would say that LakeFS is an atomic version data lake on top of object storage. And what LakeFS does in reality is basically to enrich your object storage with capabilities that we believe are missing from an object store, for the object store to be a good data lake. And the capabilities that LakeFS enriches your object store with are mainly around versioning. And the idea of LakeFS is to provide you a layer that sits between your object store, your existing object store that you use in your organization, and the rest of the applications that communicate with that store that you use in organization. And LakeFS that introduces this layer acts as a layer of manageability and reliability. So let's see quickly how LakeFS works. So what we do, we expose an API that basically is a superset of the Amazon S3 API. And this API is used by any application that up until now communicated directly with the object storage via the S3 API to communicate with LakeFS. And to do that, all you have to do is to point the configuration of the S3 endpoint of your application to the LakeFS installation. So for example, if you're using Spark, and up until now you brought from Spark directly to S3, so now all you have to do is in your Spark configuration, you have to set your S3 endpoint to point to the LakeFS installation, and then you're all set. And it's kind of like transparent, it's not kind of, but it's transparent to your application, and LakeFS will do all the magic in between for you. So the API that we expose, except for the S3 functionality that it exposes, it also it provides you with git-like capabilities, which is the versioning aspect of LakeFS. So having LakeFS in place, your object store behaves like a giant Git repository. And now what you can do, you can create branches, you can commit, you can merge between branches, you can time travel between commits to view different versions of your data. So basically LakeFS exposes all of the Git primitives that are available for your code repository, but now they are available on top of your data lake. So although that like we're comparing between code and data, bear in mind that code and data are fundamentally different, and especially when it comes to scale. So our goal in LakeFS is to give our users the Git-like experience, but having this experience scale to potentially billions of objects to multiple petabytes of data, and be as transparent as possible to you. The only change that you will see when you use LakeFS is that now you have to modify the code of your application to communicate with LakeFS in the context of a branch. You're making your application branch aware. So if up until now, to communicate directly with the object storage, what you did is to specify the bucket and the path to the object that you're trying to access. So now you'll have to prefix the path with the LakeFS branch that you're using, as you can see in this example. So here I'm prefixing the main branch of my lake. And the same concept extends also to the Hive metastore that many people are using to decouple storage and schema. So what you can do, if you have a Hive table that points to some files that are stored on a certain LakeFS branch, so what you can do is to clone that table and make it point to the branch of your lake. The idea of LakeFS is that it should work with any tool that is S3 compatible, and all you have to do is to point your S3 compatible application to the LakeFS installation, and you're all set. So let's talk a little bit about how you can use the LakeFS's data versioning capabilities to overcome the difficulties that you see in your day-to-day work with the data lakes. in managing the data lifecycle in your organization. The easiest place to get started with LakeFS is to incorporate it in your development environment. And this is something that we see and we keep hearing from any organization that we talk to, like this is always a struggle for them. So what people typically do to create a dev env today, when we don't have a convenient tool to do that for us. So what people typically do to create a staging-like environment, they either copy the whole data lake and create kind of a parallel universe where they can work in isolation. Needless to say that this is extremely expensive and also it's very hard to maintain. The second approach that people take, they sometimes like copy a subset of the data to create a dedicated experimentation environment. And this is also very hard to maintain, and typically this like improvised testing environment is not very frequently updated, and then it becomes like stale. And what happens is that organizations end up with dev env that they don't trust. So having something like Git that lets you experiment in isolation, and not only in isolation, but on top of your real production data at the same scale and with the same data characteristics, is a very, very powerful guarantee. So with LakeFS, you can do exactly that. It is very easy to experiment with LakeFS. I don't like using LakeFS, you don't have to copy data around anymore. You can simply create a branch and you get the guarantee that the data that your branch is pointing at is kind of frozen in time until the point in time that you decide that you would like to update it. And to update it, you will just merge the data from the main branch onto your branch. And also creating a branch in LakeFS, so you get to work in isolation and you are assured that no one is touching your data. And on the other hand, none of the changes that you're making to your branch are affecting any of production data or the main branch. And also, creating a branch in LakeFS is a very cheap operation. So you can decide to create an experiment branch for any experiment that you're running. So examples could be like maybe you're tuning a hyperparameter and you're creating an experiment branch for every different value that you experiment with. Or maybe you're trying a different algorithm on each experiment branch. Or maybe even like a different example would be that you might want to test changes to your infrastructure on an experiment branch. So maybe you're trying out a new Spark version and you want to test it in isolation. So you can do all of this using this branching capabilities, which is, as I mentioned earlier, very cheap. So you can do all of this in isolation. And due to how LakeFS works, so at any point in time, you have access to all the experiment branches that you created. So due to how LakeFS works, all the branches are available remotely at any point in time. So you can test, you can use it to compare the results on 2 different branches, and you can also test how other jobs in your environment are affected by the results on each branch. And this is maybe one of the biggest differences between LakeFS and Git, is that if I'm thinking about Git, so I have at a certain point in time, I can only work with a single software version that I'm like checking out on my cloned local repository, and this is the world that I'm seeing. But in LakeFS, like I can work with multiple branches that are available remotely in parallel. And in the example that you see here, so I'm using Spark to read the results from 2 different experiment branches. And then I'm using Spark also to do some aggregations on the data, and I can compare them later. And the same trick holds for Presto or any other S3 compatible application. So here I call in in this code, so I'm doing things that I would do without having LakeFS in the picture. So I'm creating an external table, and I'm pointing my table to an external location. But now I'm pointing my table to a LakeFS branch. Moving down the data lifecycle management path, during deployment is really where you can start benefit from having a tool like LakeFS in place. So working with data lake, you all know that new data is being introduced to the lake very often, like every day, every week, even minute by minute. And when you introduce new data to your lake, so you expose your environment to potential data quality issues. And sometimes those quality issues, they're not even related to any change that you did. And they're not necessarily related to a change that you did on your code or to your infrastructure. So for example, if you're using some client to fetch website events, and then this client and stream them back to your lake, and this client has a bug. So what happens is that a corrupted data is being streamed into your lake, but you're simply unaware of that. And this is also unrelated to anything that you did. So what LakeFS does is to let you create CI/CD inspired workflows to identify potential quality issues before they get into your production environment. And really the key here is that we allow you to check things ahead of time before the disaster had happened. So what you can do with LakeFS, you can safely make and update your data in isolation on a separate branch and then merge them into the production environment after running some validations. And you can also use the CI/CD inspired workflows to run some validations that will enforce best practices. So how does it work? This is very similar to the way we work today with Git or GitHub. Today, when I'm working with Git, when I'm making a code change, I work in isolation on my branch, and when I want my changes to be available to everyone in the organization, I'm trying to merge my changes back. And what LakeFS let you do is to define, LakeFS exposes a concept that's called pre-merge and pre-commit hooks. And what it means is that you can now define a set of actions that must pass before the merge or commit action completes successfully. So what you can see here in the example, I'm making a change in isolation on my branch, and then my change, as part of my change, I'm introducing 3 new files to my lake. 2 of them are Parquet file, which by the hook that I defined, they're valid in my lake, they are desired. And the third file is a CSV file, which is forbidden in my lake. So using LakeFS, the merge hook that I defined will fail. And therefore, the merge operation that I'm trying to do will be blocked, and we will prevent the ingestion of corrupted data onto the lake. And like another angle to think about this guarantee is that, like if you think about it from the data consumer side of things, so from the data consumer side, this is a very powerful guarantee, because now if I'm consuming data from the main branch, so I can be assured that I can expect a certain like a set of specific formats, and like I can make this assumption. It's very powerful. So here in this example, this is this code is premature, but I'm gonna use it to demonstrate the principle that we're discussing. So I'm using PyArrow, which is a Python library that integrates with the Arrow ecosystem. And what I'm doing here, I'm running a very simple validation, a very simple schema validation. So the first thing that I'm doing, I'm checking the diff that my changes introduce. Then I'm searching for Parquet file, and then I'm reading the metadata of these Parquet files, and I'm searching for columns named user ID. And in case that my Parquet file include columns named user ID, I will raise a validation error. And the reason why I want to do it is that user ID is a column that is personally identifiable, and this data is exposed publicly, and I don't want it to be public. So what I just demonstrated is that with 5 lines of Python code, I created a policy to my lake that otherwise it would have been pretty hard to create. Production data. We've reached the production part of the data lifecycle, and production, the production data is probably the most crucial part. And in production, errors inevitably occur. And when you run into errors, the best thing that you could do is to recover from them as quickly as possible. So LakeFS, what LakeFS lets you do is exactly that. LakeFS gives you the tool to troubleshoot and to recover from errors that occur to your production data as soon as possible. So now you can roll back your data and recover from errors and bring your data lake into a healthy state. Now you can use LakeFS to troubleshoot and investigate production errors by just looking at a snapshot of the data from a certain point in time that you wanted to look at. And you can also use LakeFS to get cross-collection consistency. So for example, you upgraded imagine that you upgraded your Spark version and you merged, you deployed the new data into the lake. The code change that upgrades the Spark version and the data that was resulted in by this change, and you deployed it into the lake. And a few days or weeks after, you identify potentially a potential data quality issue, or you notice that the infra costs had changed in your environment, and you need a way to investigate and troubleshoot. And what LakeFS let you do in such cases is you can go back and look at you can simply create a branch from the point in time where the earnest data was presented to the lake and start troubleshooting from there in isolation. Also, another thing that LakeFS provides you is that if you work with best practices, and during the LakeFS commit, you also record the corresponding Git commit, so you might be able to reproduce the holistic view of the environment at the point of error. To recap the difficulties that we reviewed, that has to do with the whole data management lifecycle. So we talked about how you can use LakeFS in the development phase to create a trustworthy dev environment without paying the extra cost of copying data and without having it to manage it yourself. Then during deployment, we reviewed how you can use LakeFS to create CI/CD inspired workflow and enforce best practices on your lake. And then finally, in production, we discussed how we can use LakeFS to quickly recover from errors. So the next topic that I'm going to touch very briefly is I'm going to give you a glimpse to the LakeFest architecture. This section is covered in much more detail in our documentation, and if you're interested to learn about our data model and the architecture, I highly recommend to read it. I'll share the links after this talk. I'll be happy to. So talking about the LakeFest architecture, we need to remember that LakeFest is not Git. LakeFest is different than Git, from Git in few aspects. The first is, of course, the scale factor. So LakeFest should potentially support multiple petabytes of data or billions of, potentially billions of objects. Another difference between Git and LakeFS is that the velocity of the changes done to the data lake is very different than the velocity of code changes that are done to a code repo. So if, for example, you have some automated process in your environment that does commit to LakeFS, or you're using some DAG, so you might end up introducing millions of commits per day to LakeFS. So it's very different from code. And the third difference is that in code, so the changes done like by anyone that works on the code are in the granularity of a line, and LakeFS, in LakeFS, the change is counted in the granularity of an object. So given all these changes, LakeFS is built differently than Git. And what LakeFS do is we expose what we call the LakeFest S3 Gateway. And this is the component that lets your applications communicate, that previously communicated with S3, communicate with LakeFS, and this is what makes it transparent to your application. And the LakeFest S3 Gateway in turn talks with the metadata manager that is responsible for all the git-like aspects that our system provides. So I'm going to use the next few minutes to show you a quick demo interacting with a real LakeFS system. And like, I hope that you see how easy it is to use LakeFS to achieve everything that we talked about right now. And after the demo, of course, that I'm going to leave some time for questions that you're welcome to ask. So let me move to the demo. And this is the LakeFS UI. What you can see here, that previously to the stock, I created one repository in my environment, and this repository called Milan. It's for our demo today. And what I'm going to demonstrate in my demo right now is how you can use Spark to interact with branches that live on my LakeFS repository, and then how I can work in isolation on different branches without affecting each other, and later merge my changes back into the main branch. So LakeFS provides a command line tool, the LakeCTL, and I'm going to use the command line tool to do most of the things in my demo. So the first thing that I'm going to do, I would like to see the repositories. I would like to list the repositories that I have in my environment. And as you can see, I have one repository called Milan that we saw in the UI. And now I'm going to list the branches that my repository has. So here I'm going to need to specify the repository name that I'm trying to list. Okay, so I can see right now that I just have the main branch on my repository. And now what I'm going to do, I'm going to also list the objects that live under this branch. And as you saw in the UI before, currently there are no objects here, so let's do that. Sorry, I forgot the branch name. Now, okay, so it returned empty, and you see that there are no objects currently on my branch. And what I'm going to do now, I'm going to use Spark to write a simple data frame into my main branch. And I'm going to go over this like few lines of code very quickly because it demonstrates everything that we talked about. So you can see here that what I'm doing, I'm changing my Spark configurations to point to the LakeFS installation. I'm working with the local installation. So instead of like to S3, my Spark currently points to the LakeFS installation using an example credentials, of course. And then what I'm going to do, I'm creating a data frame and I'm writing it to my main branch. So let's run this piece of code and let it finish. Okay. Run it again. Okay. There is no one demo that works smoothly. Try it out. We're going to spend the time together waiting for Spark. I guess that you all know the feeling. Okay, I think it's finished. Let me refresh the UI. You can see that my job completed successfully and I have this object written to my main branch. Let's look at the same view from the command line. Okay, now we can see this object. And what I'm going to do right now, I'm going to commit my changes. And now these changes are uncommitted. And if you look at the list of commits, you can also see that there is one commit that is actually the creation of the repository. Now I'm going to commit my changes to my branch. So I'm going to use the commit command, LakeFS exposes. I'm going to need to specify the name of the branch. Commit message, of course. Commit to main. Okay. Okay, so I committed the data to my branch. If I look here, I can see in the commit log that I have one commit right now in my branch. And what I'm going to do right now is to create another branch out of the main branch. I'm going to call it a demo branch. And the source branch for my branch is going to be the main branch. Okay, so now let's list the branches that we have in our Milan repository. Sorry, repo. Okay, so as you can see right now, I have two branches available on my repo. And let's see the UI view of things because I want you to see it. So I have the demo branch, and this demo branch also have the object that I uploaded to my main branch. And this operation is like, I didn't copy any data. It's a metadata operation. It's very cheap, as I mentioned in reviewing the use cases. So we have two branches. And what I'm going to do now is I'm going to use Spark. Before we do that, I want to show the data frame that is currently on the main branch. And right after we see that, we will use Spark to create another data frame and write it to the demo branch. And then we'll see how the data frame on the main branch is not affected. Okay, so this is the data frame that I have on my main branch. This is what I've written with this piece of code, as you can see here. And so now let's say you Spark to write another data frame with different content. You see that I have the word demo in this data frame. So this is the difference. Let's run this. Okay, okay, so let's see it in the UI view and then in the, okay, so I'm right now at my demo branch, and if I look at my uncommitted changes, so you can see that I'm overriding stuff. And this is the result of the Spark code that I wrote. But now if I'll run again, if I'll show you the data frame, the contents of the data frame from the main branch, you'll see that it was not damaged, it had not changed. And I got to work in a complete isolation by just creating a LakeFS branch. So let me run this. Okay, so this is the data frame that I got from my demo branch, but let's see the data frame from the main branch. So you see that it remains the same. It did not change, and I worked in isolation. So now to complete the flow, I'm going to commit my changes to the demo branch, and then I'm going to merge them back into the main branch. And then I'm going to call it commit to demo branch. Okay, now if I look at the LakeFest UI again, so I can see that I'm in the demo branch, and I have here like 3 commits because I branched after I committed to main. And if I change to the main branch, I see that I only have 2 commits in place. And now the last thing that I'm going to demo is to merge the demo branch back into master, into main. And just a quick reminder that if I would want to use the concept of the LakeFS hooks, so this is the place where it comes into play. So before, like I could define an action that says that you need to validate the schema that I wrote before merging, and this is how I'm going to use LakeFS to enforce best practices and whatever gets into my main branch, which is the production environment. So now let's merge the 2 branches. Merge. And I'm gonna do this as we're gonna see. So you see that you need to specify the source and then the destination. So the source would be the LakeFS demo branch. And the destination is going to be the main branch. Okay, so I merged, and if we go back to the UI, and now I'm in the main branch, and you can see that there are 4 commits in place. So I have the commit to main, which I did on main, and then given that I merged my demo branch onto main, so I'm seeing also the commits from the demo branch. And okay, so this is where my demo ends, and I'll leave the stage for your questions. So Andrea, feel free to take it from here, and I'm happy to answer any question. Thank you very much.
Thank you, Tal. I have a lot of questions. Maybe I can start just to break the ice. Then, if someone in the audience have other question, can also turn off the microphone and do directly or write in the chat. also in Italian, and then I will translate the question to Tal. My first question is about that. I think that in a data landscape should happen less frequently than in a code landscape, but it can happen. And I'm talking about merging conflict. If you have a merging conflict, what kind of support you give to the developer to solve the conflict? Is there a log of the file that are in conflict? I can pick up from which branch I want to take the final file version of the file or whatsoever. You are mute.
I'm muted, sorry. So I said that it's a really good question. So right now we don't have a support for like interactive merge. Like we don't provide some tool to resolve merge conflict, but we let you see the conflict, and we block merges if there is a conflict in merging.
Okay. I do another question, then I see that there is a question from Ricardo. I have another question. Of course, you said that with LakeFS, I can go back to a previous merge within my branch, and so I have a sort of time travel experience. I think that when I modify a file or I delete a file, of course, you do not delete the file from the object store, but you logically delete in some metadata that you store. If I want to define a compaction policy, let me say I do not want to have modified file in a commit that is older than 3 days, just to optimize my storage. Is it possible, or I have to do it by hand, create another bucket and start versioning that bucket?
So I think that what you're talking about is what we call retention. So
Retention, yes, exactly.
We have a feature
think...
that supports retention, and what you can do is that you can define the retention policy, the garbage collection policy for each branch, and then you say like what is the days, the default number of days that we're going to keep the data on this branch, and then to apply the retention, you need to run the retention tool that we provide. So we cover that, of course, because otherwise, like you probably at some point you would like to clean up
yes,
after all of
the
experiments. Yeah, of course.
It's not code, it's data, and so can become very, very huge the storage underlying. Okay, we have some questions. So from Ricardo, which are the main use cases where you see it in action? I think that in the presentation some are described. I don't know if you can just list the most important one.
Yes. Okay. So for during deployment, okay. So we see people using us to validate the data that gets into their lake. Either like the simple validations of validating the formats or running some tests on top of the data. So this is something that is very common. We see it's interesting because like our users, they come from different fields. We have users in the MLOps field, in the MLOps area, and also data engineers. So in the ML world, we see like people using us to experiment and to get an isolated environment and to get the copy of the data that helps them reproduce the model. And in data engineering, it's mainly to really like secure your lake and create the isolated environment and to create a real notion of development and production. So this is what we see like the coming up from our users.
So in the machine learning community, most of all for reproducibility, and in the data engineer world I see two use cases from my personal side. One is just one of the most important is to control the quality of data that is ingested into the lake. So you mentioned, for example, pre-merge hook, no? So before to merge, so you can create a branch when where you store all the data ingested from upstream system. And then before to merge these with the main branch, you can perform quality check and then decide if you want to merge or not to merge. This is one interesting thing. And the other one is that if you need also to, for example, update two different collections and you want to do that in a way that are transactional consistent, you can use the merge system to have an atomic merge. So only if the two collections are updated correctly, then you can merge in an atomic operation. That's another interesting use case. But mainly, I think, to manage all the data pipeline as we manage code pipeline. No? In fact, the question that I have also is that you mentioned that the best practice is to save when you commit. So, for example, the git commit. This is done saving the git commit in the comment of the commit, or you have some metadata parameter that I can attach to the commit.
So the second, so we have our commits can be associated with metadata, and so you can do that. And in our roadmap and in future plans that we have, and we're hoping to get also feedback about it. But we plan to implement some Git integration, something that will be more easily done with working with lakeFS and Git together.
That's great. For example, for the ML use case, when you want to keep synchronize your code with the data in order to train the model with the same code and the same data and guarantee reproducibility, that's very important. But if you do that with metadata parameter, I think that it's also possible to use this information to store other kind of watermark. For example, a Kafka cursor. If is Kafka that ingests the data into the lake, when I create a branch or when I create a tag, I can also save where the cursor was when I created that particular branch. Is another way to keep synchronized different kind of system, not the data with the code, but data in the lake with the upstream source that produced that data originally. So I can move back if I have a problem and start read from that particular cursor and repopulate the data in the lake properly. So, but we have a lot of questions, and I have already asked too much question by myself. So Dimitro, he asked if is there a TTL or retention for the oldest commit, but I think that you have already answered. I don't know if Dimitri, you can write if because it was very similar to my question, and so
right. I've just asked, written it before you asked it, but thank you. I got answer.
Okay, perfect. Then Andrea, if you want to do your question,
yeah, thank you. Thank you very much, Andrea. So thank you, Tal, for your talk. It was great. And I have a question on the merge operation. When you do a merge operation between two commits, how do you compare the data? Are you comparing the name of a file, or do you have a way to compare the content of a file, like with an hash or something? Because that's, I think, crucial.
A great question. So we compare files by checksum, like our objects, they get checksums, and it's not the name of the file, of course.
Okay, so and when do you compute the checksum before on the write session, when you write the file, or when you merge it?
When we commit the file, when the file becomes committed, so it's calculated with a hash.
Okay, yeah, great, thank you.
Okay, then we have a lot of questions from Pietro. Just the first one: are uncommitted changes written to the object storage? How are they distinguished from a committed file? Are they hidden? Okay, so also it's a 3 questions in one. Sorry.
It's great. I'm here to answer questions. So for uncommitted changes, so the object, they must live somewhere. We must store them. So they will be on the object storage, but the way that they're distinguished from committed files is that uncommitted changes being stored less efficiently than committed files. Like when you commit a file, we have a mechanism that reuses whatever already committed and like we have a way to efficiently like store this. And like if you look at basically like if you look at the bucket that backing up your LakeFS repository, so it's not something that is very readable like for human. It uses some IDs that like we provide to the object, and like the way that you should look at your LakeFS repository is from the UI and from the CLI. And so like you wouldn't notice the difference. That's my point.
Okay, and about the last thing that you said, I think that is very correlated with the other question of Pietro. What if Spark job only interact with the catalog, so Metastore, view catalog? How would you exploit LakeFS in this scenario? I do not do this question because I know the answer reading the documentation, but maybe you can also tell us if you have something in mind apart from what you have already implemented.
Yeah, okay. So Hive is like I touched it very briefly in some slides, but Hive is like a piece that we still like we have big plans to progress in this direction. So what we let you do right now is we let you a way to work with Hive and LakeFS together, but it's not like you have to copy data. You have to copy like Hive tables in order to do that. Not like with LakeFS that you don't have to copy any data to create a branch and get the copy of the data without copying it. So if Spark interacts with like Hive, so you can copy the table and point the branch that you want to that table. But if there is some like specific use case that you have in mind, we will be really like happy to hear about it. Like it's something that we hear from users very, very often. Also, I didn't mention the, like I missed the slide of the like Slack community that we have and our website and docs. So Andrea, I'll be happy to share it like with you later. And you're very welcome to join our Slack community, everyone here. And you can find like a lot is going on there. So we'll be happy to have you there.
Okay. I think that, I don't know if we have some more questions. Yeah, another question from Mario. Could LakeFS enable also temporal warehousing for traditional data dumps? Example, CSV, relational database object dump, with changing metadata git release branches?
I'm not sure that I understand the question.
Sorry, I repeated the question because I read it very, very badly. Could LakeFS enable also temporal warehousing for traditional data dump with changing metadata git releases branches? So I also try to understand the question. Give me one second.
I'm not sure that I understand. If you can clarify.
I don't know, Mario, can you rephrase the question, or if you want to turn your microphone and do it by yourself? Because I am not sure to have understand your question really well. Okay, so we have said we will share the slides and maybe at the beginning of the next week, the video recording will be online on our YouTube channel.
And you can also like join our Slack channel. I'll paste the the link here.
Okay.
In the chat, and also like when we share the slides.
Perfect. And then if you want to share with me all the resources and link that you want to share when I publish the video, then in the comment I put all the link to the resource that you find useful. Of course, the slide, but if there are some other resources, the Slack channel or your blog, your website, I can put everything online just behind the video recording. I think that if there are no more questions, I just do my last question as usually, and then we can close for today. So Tal, if you can maybe tell us something about your roadmap in the short term, in the long term, which direction you plan to go with the product.
Let me share it even because it's we're an open source product. and like everything is public, including our roadmap and including our GitHub project that you can like every time that you want, you can track whatever we're currently working on. So our roadmap is available on our website. And
okay.
so yeah, so like you can all look at it, but really like the burning issues that we see that are coming. So something that we're going to release very soon is a feature called protected branches. And protected branches means that you can add like additional protection to your branch, and you can like restrict some branches from certain operations. Like you can block like writes or commits to a certain branch, and to like create a really like protected branches that are of course dedicated to production environments. Then another topic that also came up here is the Hive Metastore, that is a burning issue for our users, and we would like to come up with a more holistic solution for that. Another thing that I mentioned also in this talk is the hooks concept, which is the git-like actions that we support before commit and the merges. And this is something that we would like to improve the usability of this feature so that it's very easy to use. These are like the things that are, except for that, we're working to incorporate some like authentication and authorization abilities into our system. And like it's very actually exciting to share the roadmap with you, because like if you look here, we have a GitHub issue for each one of the items in this roadmap, and what we really want to see is that the community is involved, and like you comment on issues and you tell us what are the exact use cases that are burning for you, and then we can take it from there and like move forward with that. So if you have any comments or suggestions or questions, you're more than welcome to comment in our GitHub.
Perfect. Wonderful. Okay, so I think that it's all for today. Again, thank you very much, Tal, for the talk. Really interesting. Thank to everybody that joined online today, and I think that we'll be back in a month or so, as usual, with the next event of the Meetup. So keep in touch, follow us on our Meetup page or on LinkedIn to be notified of the next event that we are going to organize. As I said at the beginning, if you want to propose a talk, you are more than welcome. So thank you, everybody. Bye-bye, and see you next time.
Thank you very much. Bye-bye.
Thank you, Tal.
Bye-bye. Bye.